In this video, let's try to solve the recursive definition of a power a to the n, where a is non-zero. So a is not 0 and n is a non-negative number. So n will be z plus element. So we could start at the base case. The power a to the power 0 will be 1. And how about the basis, the recursive step? The recursive step will be, say, a to the n. In terms of its previous term, that could be, so this should involve the previous term, say a to the n minus 1. So somehow this could be multiplied by a. So if you multiply them, the negative 1 will be just cancelled. So you could also express it in terms of the next term, n plus 1, and the previous term, so a times a to the n, the previous powers. So in that case, it will still give you a to the n plus 1. So let's try to code this one. So we have, say this is pow, so let's just call it pow, and let's input a non-zero integer. So a should be restricted, so let's just say that this is int a raised to the power n. So int n. And if n is equals to 0, if the power n is 0, let's just return 1. Else we're going to return, so basically this second one will compute the next term, while this one will compute the actual power. So we basically use this in the algorithm. So return a times the power of a raised to n minus 1. This one, the previous. So that's it. We could test this with 1, 2, 3, I think. So that's equally valid. Let's just change the name to pow. I'm not sure if there's a built-in function pow, but most likely there's none. Okay, so it needs 2 input, so let's just say give an a which is 2, for example, and let me just put it here. So a2, so a squared So this will be f of 1, f of 2, f of 3, f of, say, let me just change this to a. And okay, so let's run this. I meant to make it %d. Okay, let's try to run this. Okay, so first power is 2, 4, and then 8, and then 16. So it works. So as you can see, the recursive definition is readily translated into an algorithm or code. And again, the way this works is when your program enters the main, it will basically read your function definition and or function call. So this is the call to the function, and it will go to its definition. So because this part is the definition, and then within this definition, the function will check whether it's 0. If it is 0, it will simply return 1. In our case, it's not 0, so it will go to the else case, and then it will compute. So a times the power of a raised to n minus 1. So this is the previous element, or the power of the previous element. And basically it will call the function again until it reach the base case, which is 0, and it will return 1, and it will compute and substitute and then recall the function, and then when it ends, it will go back to the caller of the function. So that's the solution to this problem.